our previous video, we looked at how we can use sum and difference formulas to expand expressions in order to evaluate trig functions at uncommon angles. In this video, what we're going to do is we're going to take a look at how we can just use this sum and difference expansion to help us maybe simplify expressions that we have that involve sines, cosines, and tangents of sums and differences of angles. So when we look at this right here, this first example, we have some tangent of a sum of two angles here. What I want you to notice is that we happen to be aware of an exact value for one of these angles. It's 3 pi, but the other angle here is theta, and so it's left kind of general. Don't let that bother you. Always try to rewrite this as some sort of an expansion to see where it gets you. So that's what we're going to do here. We're going to use our tangent sum and difference formula to do this here. So remember that our tangent sum and difference is if we have a u plus v inside of our tangent, on top of our ratio that we get here, we get the tangent of u and the tangent of v, and this will always be plus or minus up here if this is plus or minus over here, meaning that they're the same sign. And on bottom, we always have a 1, and then the product of these two things over here, tan u and tan v. But this is minus plus down here, meaning that this sign is going to be opposite of whatever we recognize as being a sum or a difference on the left. So looking at our sum here, we could kind of identify that our u in this case is the theta that we see inside here. This is our u. And our v in this case is like our 3 pi. So to kind of expand this here, let's maybe bring this out over to the side here. We're going to get this ratio that we recognize we would get. And I'm real big on just maybe filling in some blanks. I know that this was a plus over here, so I'll put a plus on top. So we have the tangent here. And then on bottom I have 1. This will be a minus because the top's a plus. And we have the tangent of u and the tangent of v. So, kind of taking this idea that see where this gets us. If u is theta, we'll put that in front, and if v is 3 pi, we'll put that in back. It kind of always preserves this order here. And then we'll go through and say, well, for which of these can we actually evaluate? And in this case here, I know that we can evaluate for the tangent of 3 pi and the tangent at 3 pi here. So, what would be our tangent at 3 pi? And you got to kind of take a look at this as we always use our unit circle to evaluate for trig ratios at common angles. So 3 pi, well, that'd be like a 2 pi plus another pi, so we'd be here. And as far as the unit circle is concerned, when we talk about, okay, well, what is our tangent out here? Tangent is always, remember, y over x. And so in this case, our tangent value here is 0 over 1. Our tangent of 3 pi is 0 over negative 1, which is 0. So in this case, we're just going to rewrite what we have here, and notice that the tangent of theta is just kind of going to be left on its own. It's a general angle. So we're just going to leave that alone. Let's try that again. Much better. But here we're just going to insert a 0 for its value. And then on the bottom we have 1 minus the tangent of theta. But this is also times a 0. And what do we know about anything times 0? Well, it produces a 0. So on top we get tangent of theta plus 0. And on bottom we get 1 minus 0, which kind of leads us to this conclusion. We get tangent of theta over 1. So you can see that this tangent of theta would be the same as the tangent of 0 plus 3 theta, but it's a little bit simpler way of saying it. So let's take a look at maybe one more here. How about the cosine of theta minus 3 pi halves? Could we maybe expand this and see where it gets us? So in this case, let's see where we get. In this case also we have a cosine sum and difference, so we have a u minus a v. And with respect to cosine of u minus v, remember that if it starts with cosine on the left, it starts with cosine on the right. And the cosine does not alternate, so it's cosine, cosine. It'll be backwards whatever this sign is on the left, so plus, and then we keep sine, sine, and we'll just go through and we'll just plug in our angles here. So our u in this case is, again, it's like a theta here, we'll put that in front, and our v is 3 pi halves. If you're concerned about the negative, should it be negative 3 pi halves? No, because this negative only impacts how we treat this sign right here, so we won't worry about that here. So clearly we're not going to be able to evaluate for this cosine of theta here, but cosine at 3 pi halves, again, let's take a kind of a sketch on our unit circle approach here. 3 pi halves terminates down here. And so for what we have down here on the outside for our ordered pair, 0, negative 1, our cosine value here would be our x value, and this is 0. So let's go ahead and replace our cosine of 3 pi halves with its value 0. That looks too much like a theta. Let's try that again, 0. And we're going to say that this is plus sine of theta. Okay? And then our sine at 3 pi halves, what is its value? In this case, it has a value of negative 1, so we'll put a negative 1 here. So to rewrite this, what are some things we can see happening? Well, I can see that this all becomes a 0. Anything that has a factor of 0, its product is 0. And on the right here, we get a positive sign times a negative 1. So this initial statement we could just rewrite as the negative sine of theta, which would be a little bit easier way to interpret this. It's just an angle of theta instead of theta minus 3 pi halves here. So like I said, use your sum and difference formulas to expand these expressions properly, and then evaluate at any trig ratios you know the angles for and kind of try to simplify from there. Cheers.